Welcome to the Deep Dive. We're the place where we try to unpack complex topics and pull out the most important nuggets of knowledge for you.
That's right.
Today, we're diving deep into something pretty fascinating, optimizing how you interact with large language models, LLMs, specifically within the Snowflake ecosystem. We're talking Snowflake Cortex here.
Yep. And we've got a good stack of insights lined up. We'll be looking at different ways to prompt these models, different styles, plus how you can automate all that, which is crucial.
And also tackling that tricky topic of context windows, right?
Yeah.
How much information can these things actually handle?
Exactly. Token limits, context size, all that jazz.
Okay, so our mission today, cut through the noise, get you the core understanding you need. We want you to walk away really knowing how these tools work under the hood.
Let's get into it.
All right, so first things first, talking to these LLMs. It's not always the same approach, is it? Different jobs need different instructions.
Absolutely. You wouldn't use a hammer for every job, right? Same idea here. These different prompting styles are basically different tools for guiding the LLM.
Makes sense.
Let's start with few-shot prompting. This is where you give the model a few examples right in the prompt itself, kind of like showing someone, here's what good looks like, before asking them to do it.
Okay, like that email example we saw, where you show it, this is spam, this is not spam, maybe a couple of times.
Exactly. You give it example 1, congrats, you won, spam. Example 2, meeting moved, not spam. Example 3, big sale, spam.
Right, and then you give it a new one, like, can we discuss the report? And it knows, based on those examples, that it's not spam.
Precisely. And in Snowflake Cortex, our source material shows this applied to, say, predicting salary. You might give it Alice, manager, 100K, Bob, developer, 80K.
Okay.
Then you ask, what about Charlie, a tester? The model learns the pattern from those structured examples. It's really very effective when you have clear patterns like that. Think about classifying documents or customer feedback. Huge time saver.
All right, avoids having to write tons of complex rules yourself.
Totally.
Okay, so few-shot uses examples. But what if you don't really have examples handy? Or maybe the task is simpler. What then?
Good question. That brings us to zero-shot prompting. It's pretty much the opposite. Here, the model tackles the task without any examples in the prompt.
So you're just relying on its general knowledge.
Exactly. You're banking on its pre-training. Think about summarization. You could just say, summarize this paragraph in one sentence. Electric cars are advancing fast, cutting emissions, changing transport.
And it just does it without seeing an example summary first.
Yep. It draws on its understanding of language and summarization. In Snowflake Cortex, you might use this for quick hits, like predicts the typical salary for a tester in software.
Okay.
It's good for straightforward things, but, if the task is really nuanced or specific to your business, zero shot might be a bit too general sometimes. Might not give you exactly what you need without more guidance.
Right, it might guess wrong if it's too niche. Okay, that makes sense. Now, this next one sounds really interesting. Chain of thought prompting.
Ah, yes, chain of thought, or COCA. This is where you encourage the model not just to give you an answer, but to explain how it got there. Step-by-step reasoning.
Why would you want that? Isn't the answer the main thing?
Well, sometimes, yes. But for complex problems or things where you need to trust the result, seeing the working out is crucial. Think about multi-step calculations or maybe diagnosing a problem.
Or like compliance stuff, where you need an audit trail.
Exactly. Perfect example. That explainability is gold in regulated areas or for big decisions. Our source had that simple math problem. Tom has 3 apples, buys 4 more, gives 2 away. How many left? Explain step by step.
Right, and the model would actually say like, okay, step 1, Tom starts with 3. Step 2, he buys 4, so 3 plus 4 is 7. Step 3, gives 2 away, so 7 minus 2 is 5. Final answer, 5 apples. You see the whole thought process.
Precisely. And back in Snowflake Cortex, with our salary example, instead of just asking for Charlie's salary, you could say, Alice, manager 100K, Bob, developer 80K, managers earn more than devs. Testers usually earn a bit less than devs. Given this, what's Charlie the tester's salary? Explain step by step.
Ah, so you're guiding its reasoning based on relative relationships.
Yep. It helps the model structure its thinking based on the context you provide, making the prediction much more transparent and, frankly, often more accurate for complex scenarios.
Okay, this is powerful stuff. We've got few shot with examples, zero shot for direct tasks, chain of thought for reasoning. But let's be real. If you're dealing with tons of data, You can't sit there typing these prompts one by one, right? How do you actually scale this up?
No, you absolutely cannot. Manual prompting just doesn't work for, large data sets or if you need this running continuously. It would be completely impractical.
So what's the solution?
That's where Snowflake's automation tools come in really handy. Specifically, we're talking about streams and tasks.
Okay, streams and tasks. How do they work together? Let's break that down.
Think of a stream, maybe called prompt stream, like a sensor attached to your table of incoming requests, say prompt requests. It just detects whenever a new prompt request arrives in that table.
Okay, so it watches for new work.
Yeah.
And the task.
The task, let's call it process prompts, is the automated worker. You set it up, tell it which virtual warehouse to use for compute power, like warehouse compute EH.
Right.
And you give it a schedule, maybe schedule 5 minutes. So every 5 minutes, this task automatically wakes up, checks the stream.
Sees if there are any new prompts waiting.
Exactly. And if there are, it processes them.
Wow, okay. And what does processing look like in the code? What's the task actually doing?
The logic is surprisingly neat. It's essentially an insert statement that uses the Cortex function, something like insert into prompt responses select requested snowflake.cortex.complete prompt as response current timestamp is processing that from prompt stream.
Whoa, okay, let's unpack that. It's taking the requested and the prompt from the stream.
Yep, from the new rows the stream found.
Sending the prompt to snowflake.cortex.complete, which is the function that talks to the LLM.
Correct. That gets the actual response from the model.
And then it saves the original requested, the response from the LLM, and the time it was processed, current timestamp, into another table, prompt responses.
You got it. All automatically every 5 minutes or whatever schedule you set.
That is seriously efficient. So you
Right.
set it up once, and it just runs, handling potentially thousands or millions of prompts without you touching it.
Pretty much. It makes using LLMs at scale genuinely feasible within your existing data workflows. It's not just about saving time, it unlocks use cases where LLMs are deeply embedded in, say, real-time data processing or automated analysis pipelines.
It really changes the game from one-off queries to continuous intelligence.
It's a big shift. Think about analyzing customer support tickets as they come in or enriching product descriptions automatically.
That sounds fantastic. Almost too easy. Are there any, common things people need to watch out for when setting this up? Best practices, maybe?
That's a fair point. While it's designed to be straightforward, good practice is definitely to monitor that prompt responses table, especially early on. Check for any errors or unexpected outputs from the complete function.
Makes sense.
And also, keep an eye on your warehouse usage. Make sure that compute WH is sized right for the volume of prompts you expect. You don't want it to be a bottleneck or, conversely, way oversized and costly.
Right. Cost optimization is always key. Okay, so we can automate the prompting, which naturally leads to another big question.
Yeah.
How much stuff can you actually feed into these prompts? We hear about context windows and token limits. How does Snowflake Cortex deal with that?
Yeah, that's super important. The context window is basically the amount of text, the prompt, and the expected response that the model can handle at one time. Think of it like it's short-term memory.
And they have limits, right?
They absolutely do. Different models have different limits. What's interesting with Snowflake Cortex, though, is that a lot of this management is implicit.
Implicit.
Meaning, the Cortex functions themselves often handle picking an appropriate underlying model that can fit your prompt and manage the token limits behind the scenes. You don't typically have to specify, use model X with Y token limit in your SQL call.
Okay, so Snowflake tries to figure it out for you. That sounds simpler.
It definitely simplifies the user experience. You focus more on the task, less on the specific model mechanics, but it also means you don't have direct control over the exact token count for a specific model through the SQL interface, at least as of, the time of this recording in 2025.
Okay. So it's convenient, but maybe less transparent if you really needed fine-grained control.
Potentially, yeah. It's a trade-off. But you're not completely in the dark. There's a really useful best practice for estimating your token usage.
Okay.
You can use character count as a proxy. The general rule of thumb is that 4 tokens are roughly equivalent to 100 characters of text.
4 tokens per 100 characters. Okay, that's handy. So you can look at the length of your prompt text and get a ballpark figure.
Exactly. It helps you anticipate if your prompt might be getting too large for typical models. Our sources actually had a great table, long context prompts, simulating this.
Right. I remember seeing that. It had prompts of different sizes.
Yep. It simulated a few scenarios. One prompt around 16,000 tokens, sort of like a GPT-4o limit might handle. Another much larger one around 200,000 tokens, more like a Claude 3 model. And even a huge one, like 1 million tokens, which is in the ballpark of something like Gemini 1.5.
Wow, 1 million tokens is massive.
Yeah.
And you could estimate those using simple SQL.
Yeah, the SQL was pretty straightforward, just calculating the length, select prompted, length prompt text, as char count, length prompt text 4, as estimated tokens from long context prompts. Gives you the character count and that estimated token count based on our rule of thumb.
So you can estimate, but just to be clear, when you actually run the query in Cortex, Snowflake automatically figures out if the chosen model can handle it. You don't get an error just because your estimate was, say, 17K instead of 16K.
That's the idea behind the implicit handling, yes. Snowflake aims to route it appropriately or handle it gracefully. Now, looking further out, or if you were perhaps using different interfaces like Snowpark or external APIs where you do specify models, and you have truly enormous inputs way beyond typical limits, then the concept of chunking or trimming your prompts becomes relevant.
Ah, okay. Like breaking a huge document into smaller pieces before sending it to the LLM. Like that conceptual pseudocode using split part or list tag.
Exactly that. While Cortex might handle a lot implicitly now, understanding how you could break down massive text into manageable chunks, maybe process them sequentially, or summarize parts first, that's a valuable technique for more advanced scenarios or future capabilities where you might need explicit control over very long contexts.
Good to keep in mind for complex cases or down the road. Okay, so let's try and pull this all together for everyone listening. We've unpacked these different ways to talk to LLMs in Snowflake Few-Shot using examples, Zero-Shot for direct tasks, and that chain of thought for seeing the reasoning. Really useful tools depending on the job.
Yep, different styles for different needs.
Then we saw how Snowflake lets you automate this whole process using streams and tasks. That's huge for scaling up, taking the manual grind out of it.
Absolutely key for real-world deployment. Turns it from a manual task into an automated workflow.
And finally, we tackled context windows. While Snowflake Cortex handles a lot of the complexity implicitly, like model selection and token limits, we learned that handy rule of thumb 4 tokens per 100 characters to estimate usage. And we touched on chunking for potentially massive future inputs.
Yeah, the implicit handling is remarkable, really. It abstracts away so much back-end complexity, which actually brings up an interesting thought. Well, if platforms like Snowflake Cortex increasingly handle the model selection, the token limits, maybe even some basic prompt optimization automatically, how does that change the role of, say, a prompt engineer? Does the focus shift away from tweaking specific model parameters and more towards clearly defining the desired business outcome and structuring the input data effectively? Less granular management, more outcome definition. What do you think stands out from our dive today?
That's a really interesting question to ponder. Definitely food for thought about where this is all heading.
Indeed.
Well, that's all the time we have for today. Thank you so much for joining us on the deep dive.
Thanks for listening.
Until next time, keep exploring.